Today we're going to be talking about conic sections. Now, conic sections are the curves we get when we make a straight cut in a cone. As shown below, there are four interesting conic sections: circles, ellipses, parabolas, and hyperbolas. Let's go ahead and take a look at the equation of a conic section. The graph of the equation ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a and b are both non-zero numbers, is a conic. If a or c is equal to 0, then we have a parabola. If a and c are equal, then it's a circle. If a and c have the same sign but different values, then we have an ellipse. And the last case, if a and c have opposite signs, then we have a hyperbola. Take a moment to make some notes on the illustrations below to keep the different equations separate. The first type of conic that we are going to be looking at are going to be ellipses. An ellipse is the set of all points in the plane that the sum of their distances from two fixed points, called the foci, is constant. So here we have an image of an ellipse, and these 2 points right here, F1 and F2, are called the foci. And ellipses have the property where if you take any point on the ellipse, if you add the distance from that point to one of the foci plus the distance from that point to the other foci, they should all be equal distances when you add those up. So the sum of these line segment lengths should be the same as if I went here on the ellipse and I added this distance plus this distance, or if I went let's say here and I added this distance plus that distance, assuming that my line segment is straight, those should be equal. Let's go ahead and take a look at the ellipse that is longer horizontally. It is given by the equation x squared over a squared plus y squared over b squared is equal to 1, where a and b are both positive numbers and a is greater than b. It has the following properties. The vertices will be located at plus or minus a, 0. The major axis will be horizontal and have a length of 2a. The minor axis will be vertical and have a length of 2b. The foci are located at plus or minus c, 0 and can be found using the equation c squared equals a squared minus b squared. The graph of this can be seen below on the left-hand side. So here, when you have this equation, that is associated with this graph here. And notice that we have our foci here, and we can locate the major axis. The major axis is this axis here, and then the minor axis is the vertical one that goes there. Let's now take a look at the ellipse that is longer vertically. It is given by the equation x squared over b squared plus y squared over a squared equals 1, where a and b are both positive numbers and a is greater than b. So a lot of this stuff is similar. The vertices will be located at 0, plus or minus a. The major axis will be vertical and have a length of 2a. The minor axis will be horizontal and have a length of 2b. The foci are located at 0, plus or minus c, and can be found using the equation c squared equals a squared minus b squared, and the graph of this can be seen above on the right-hand side. So this equation here is associated with this graph. Let's go ahead and look at some examples now. Before we jump into example 1, let's quickly define eccentricity. So when you have an ellipse, the eccentricity E is the number E equals C divided by A, where C is equal to the square root of A squared minus B squared. The eccentricity of every ellipse satisfies the inequality 0 is less than E, which is less than 1. Example 1 says, find the vertices, foci, and eccentricity of 5x squared plus 6y squared equals 30. Determine the length of the minor and major axes and sketch the graph. Check your graphing calculator. Check your graph using a graphing calculator. All right, so as we have it right now, our equation doesn't really look like either of these forms. So what we're going to have to do is we're going to have to rewrite our equation. So what I'm going to do is I'm going to take 5x squared plus 6y squared is equal to 30, and I'm going to divide both sides by 30, and if I do that, I'm going to get x squared over, let's see, that should be 6, and then plus y squared over 5 is equal to 1. All right, so now we have it in the form that we want to. And remember, A is always larger than B. So the scenario we're going to have is this first equation here, which tells us since our A value is underneath the x squared, that it's going to be longer horizontally. And so this is in the form x squared over a squared plus y squared over b squared is equal to 1. So that tells us that we know a squared is equal to 6 and b squared is equal to 5. And if we take the square root of both sides in both of these scenarios, we'll find that a is equal to the square root of 6 and b is equal to the square root of 5. So from here, we know that c is equal to the square root of a squared minus b squared. So let's do that. C is equal to the square root of 6 minus 5, which is going to end up equaling 1. And that's going to help us locate our foci. So we know that our foci are at plus or minus c comma 0, which in this case our c value is 1, so plus or minus 1 comma 0. We can also figure out our eccentricity. I'm just gonna use E. That's equal to c over a, which is 1 over the square root of 6. And normally we want to not have square roots in the denominator, so I'm going to rationalize that and rewrite that as the square root of 6 divided by 6. Now, remember that the eccentricity must be a number between 0 and 1, so let's plug that into our calculator and make sure that we are doing that correctly. So square root of 6 divided by 6, and that is in fact a number between 0 and 1, so it's approximately 0.41. So that looks good there. So let's see, we have found the eccentricity. We have found the foci. We need to find the vertices. So we know that the vertices are located at plus or minus a comma 0, which in this case, our a value is square root of 6. Okay, so we've located our vertices. We want to determine the length of the minor and major axes. So I'm running out of room. I'm going to erase this. Okay, so the major axis length is equal to 2a, which is 2 root 6 in this case, and then our minor axis length is equal to 2b, which is 2 root 5 in this scenario. Okay, so let's go ahead. We've found the minor and major axis lengths. And now we just need to graph this. So here's my y-axis, here's my x-axis. I'm going to scale this so that, let's see, 3 of these tick marks represents 1 unit. Okay, so we know that our foci are located at plus or minus 1, 0, so I'll plot those. There are my 2 foci, and my vertices are at plus or minus the square root of 6, so let's see what the square root of 6 is. That's 2.4. I'm just going to round it to 1 decimal place. So this is plus or minus 2.4, 0. Let's see, that's going to be like right there and right there. And then we also know that there are going to be points at 0 plus or minus b, which is 0 plus or minus the square root of 5. So that's 2.2. So it's not going to be a huge difference, but there's going to be a point there and a point there. And now I can go ahead and draw this, and it's going to kind of look like a circle. However, it is slightly wider than it is taller, and it is an ellipse. Okay, so that concludes graphing. Example 2 says, find the equation of the ellipse with foci on the y-axis that has major axis of length 4 and a minor axis of length 2. So if the foci are on the y-axis, that means that it's going to be like a tall ellipse, and it's going to look something like that. And we know that the major axis has a length of 4, which tells us that, and let's go ahead and make the assumption that this ellipse is centered at the origin. So if it has a major axis length of 4, then the distance from the center to the top would be 2, and the distance from the center to the bottom would be 2, so that it's 4. So we know that there's going to be a point on our ellipse there and a point on our ellipse there, because notice that the distance between 2 and -2 gives us 4. And then we know that the minor axis has a length of 2, and so notice that we'd get 2 between -1 and +1, so we know that there's a point there and a point there on our ellipse, and I can kind of connect this now so that our ellipse looks something like that. And the goal of this question is to come up with the equation. So we have x squared plus y squared equals 1, and the denominator for x squared is going to be b squared, and then for y squared we'll have a denominator of a squared. And we know that the major axis length is 4, and from up above we know that that tells us that 2a is equal to the major axis length, which is 4. So if we divide both sides by 2, we find that a is equal to 2. So in our equation, we can put a 4 here since we know that a squared is equal to 4. So now we need to figure out what b and b squared are. We know that 2b is equal to the minor axis length, which is 2 from right here. And then if I divide both sides by 2, I get b equals 1. And then if I want to calculate b squared, that's also going to be 1, so I would put 1 there. And this is the equation of the ellipse that we are looking for. And that concludes this video on ellipses.